Maximum product subarray. So this is a medium difficulty level, but I did find it to be quite difficult. I came up with a solution that is not optimal, that is lengthy, and what I have here is one of the top solutions, which is very elegant and not that intuitive. So I spent some time figuring out why this works. This video will explain why this specific algorithm works. There are other algorithms that work as well that are more intuitive, but this one is a little tricky, so I wanted to explain this one. So in order to get the maximum product subarray from an array of integers that can be positive or negative, we have these different cases. The first case, the easiest, is if we have all positive numbers, then we just, of course, take all of them. That will be the maximum. Then we have the case of an even number of negatives. Then we can also just take all of them to be the maximum. Now we have the tricky case of an odd number of negatives. Now, in order to get the maximum product that is a positive from an odd number of negatives, unless we only have one single negative number in the array, if we have 3 or 5 or more, then that resulting maximum product subarray that we're looking for should be a subarray containing an even number of negatives. Now we have to think, so we have an array of an odd number of negatives and we want to get an even number of negatives from this. So which is that one negative number that we are not using? Or maybe even more, maybe 3 negative numbers. So right now we don't know which part of the array that we're not using. So let's think. Naturally, we could remove the part leading to the first negative number, and then we use everything that's left. Then we have an even number of negatives, so that is a positive number. Or we take everything all the way until the last negative, so we take everything there to be a positive number as well. Now, what about the cases with those negative numbers in the middle? Would it be possible that, let's say, this case, could we have something like this? 4 integers, then we have a -2, and then 6 integers. Would it be likely that one of this part can be the maximum product subarray? So that took a little more thinking as well. First, I thought it could be likely, and in that case, this solution solves it, because what it's doing here is taking the prefix and the suffix product. So that does cover all the cases here. But then when I thought about it more, I realized that it is actually not likely, because if we do have negatives here and negatives there, we could always construct a bigger number. So for instance, here let's say we have 2 or 4 negatives or even 6, but in total we have a positive number here. And let's say we have 2 negatives over here. So in that case, instead of taking this to be the maximum, we can always grab one of the negatives and then get a bigger number. Same thing with the other way. So this specific case of picking a negative number in the middle and then one of the left or right parts will become the maximum should not exist unless the negative 2 is actually the first or the last negative number in the array. So that is an interesting observation as well. What else? Now we have the case of having zeros in the array, which is also very tricky. And what we want to do every time we see a 0 is that we want to recount, because when you multiply by 0 you get 0. So then we want to start our counting going from 0, so the next one will just be clean and then going from as if it's from the start again. So that explains why this part is or 1. It's cleaning out everything leading up to the 0 so we can start fresh again. And when you leave a 1, you are just giving it a fresh start, because 1 multiplied by anything will just be that. So this algorithm is doing the following. We have the original array, we have the reverse. It's just a simple way to do the prefix and suffix. You could also do it like normally without reversing it, but this is just a quick way to do it. So what this is doing is calculating the prefix product. So we have the first element, and then the second element is the first times the second, and the third is the first times second times third, and so on. So then we also do that for the reversed array, and that's how we get the suffix product. And now we want to find out the maximum of those, of all the prefix and suffix product possibilities. So that's it. That explains why this algorithm works. Definitely very, very smart and nothing I can think of. So very impressive. Alright, so more LeetCode next time. Bye.